at the individual models, you can see that black line is far above them beyond 3 months lead time. So, 3 to 7 months lead time, the CNN model was doing far better than any of the dynamical models. So, this gives us hope that we can improve the Indian Ocean dipole predictions by using ANN, CNN and other AI deep learning techniques. So, talking of AI machine learning, we know that we can use these techniques together with dynamical model to produce what we call the digital twins. So, we have the real world, we have the virtual world, the model world, either statistical or dynamical. And by combining observation coming from the real world, simulation results, prediction results coming from the model world, we can combine them, then use the AI technique to develop a different information system. Predicting something is one thing, but developing information out of that is another thing. So, we need AI both for predictions as well as creating information that will be useful for the society. So, by combining observation, model, AI, we plan to develop some kind of digital twins with smart interfaces, which can be used by both specialist researchers as well as general public for various societal applications. This is one of the first version of that kind of interface we are developing at Jamstack. So, these kind of 2-dimensional, eventual idea is to produce a 4-dimensional virtual earth, 3-dimension x, y, z and also time. And also on top of that, we will add some of the analysis tools, statistical dynamical analysis tools that can help general public to take decisions based on their own needs. This is just the first version of the 2-dimensional virtual earth, taking all the predictions in it, observation, reanalysis, prediction in it, and providing an interface. You can go in, click and either see the simulations or click any point to get a time series, or go to the indices. There are several indices, Nino3 index, dipole mode index, monsoon index. Those can be seen, Modoki index. Those can be seen and also downloaded. These indices can be downloaded as text file. We also have several ocean models providing very high resolution simulations all over for the globe. So, the idea is like, okay, we have the digital twins and we have various tools, then that can provide a smart interactive interface independent of which kind of media you are using, laptop, smartphone, whatever. Then this kind of interface can provide you real time information as well as predictions and various informations that can be applied for early warning and for the needs of stakeholders. So, this is the idea, like the farmers, they do not know whether it will be flood or drought, flood, extreme events, whether it is ENSO, IOD, he does not understand how to react to different predictions. So, digital twin will give him direct information. Okay, this is the situation happening now. You should go and optimize your water use, fertilize, put the pesticide or harvest, and depending on different state of the weather and climate in that region. In some sense, it will also help reducing carbon dioxide by reducing emissions from inefficient inputs, optimizing soil management and enhanced soil organic carbon sequestration. Future projections of IOD models try to say that there will be consistent increase in extreme positive IOD frequency, because the mean state in the Indian Ocean is helping kind of having more positive or frequent positive IOD events. consecutive positive IOD event, because the western side is getting warmer, and it is creating a kind of thermocline slope which is favoring upwelling on the eastern side, the Sumatra side. So, that will favor more positive Indian-Ocean dipole in the future climate, because the SST gradient will help the winds, and strong winds will cause more upwelling on the eastern side, downwelling on the western side. So, East Africa will get flooded, Indonesian and Australian region will get drier. However, the upwelling will give better ecosystem in Java Sumatra region. So, I already said the mean set shift, which will be more like positive IOD, and we have more consecutive IODs. Maybe it will become more like IOD like mean state, positive IOD like mean state, and that also will influence the interbasin interactions, because we have seen that IOD can influence the periodicity of ENSO, the predictability of ENSO, and the intensity of ENSO. So, that kind of mean state change in the Indian Ocean will kind of help more El Ninos in the tropical Pacific. However, if we have strong easterlies, then that will lead to more central Pacific El Ninos or the El Nino Modokis. So, depending on how the mean state behaves in the future, we will have positive Indian-Ocean dipole combined with El Nino Modoki or El Ninos in the Pacific. So, this is the summary of the Indian Ocean dipole phenomena, the air-sea interaction happening in the Indian Ocean. As you have seen, IOD is the leading mode of interannual variability in the tropical Indian Ocean, defined by east-west SST gradients coupled to atmospheric circulation. It has both regional to global impacts that include modulation of Asian Australian monsoon, extreme rainfall, the Indian monsoon, the droughts, the marine heat waves. So, if you have negative Indian Ocean dipole, you have marine heat waves. In the eastern side, if you have positive Indian Ocean dipole, you have marine heat waves on the western side, and that affects the ecosystem over ocean. Similarly, if you have more rain or less rain over land, it affects the ecosystem, agriculture, farming over land. Predictability is moderate compared to ENSO and seasonally dependent, with useful skill mainly coming during boreal summer and fall, and has shorter lead times compared to ENSO. We have seen that the dynamical predictions are good 3 to 4 months ahead. The statistical model are now improving that skills to a longer lead times, taking it to 6 to 7 months lead time. And I hope by combining the dynamical predictions with these kind of statistical predictions, we will be able to improve the predictability of IOD and make it comparable to ENSO. Future projections are highly uncertain. Models disagree on the trends in IOD frequency, amplitude, and skewness. But at this moment, we see that the mean state is favoring to more positive Indian Ocean dipole. So, in the future climate, we may expect frequent IODs or even consecutive positive IODs, which will have different impact on different parts of the globe. Indonesian region will be drier, the Indian central part of India will be wetter, but other parts will be drier. Australia will be drier, whereas East Africa, Kenya, Somalia, and Tanzania, some of the regions will be wetter than normal. Some of those regions may expect extreme floods. So, that is the overall scenario of what is happening to the IOD at this moment, how its predictability, and the predictability of IOD is helping the agriculture, the infectious diseases predictions and the water management in some parts of the Indian Ocean Rim countries. We have started using the IOD predictions, and we hope to develop more applications, especially through the digital twins. Digital twins will help us to disseminate the information using AI, machine learning, and different interface tools, which can be used by both experts like researchers, and also general public and the users, stakeholders in agriculture, fishery, water management, and even stock exchange and economic and energy. Okay, I'll stop there.